Good afternoon. We are going to solve some problems involving the laws of exponents and the rules of logarithms. So the first thing that we're looking at right now is we are going to look at the laws of exponents to simplify this. Some students get confused because we have a 3 here and they don't understand why they don't do 3 divided by 3 and get 1. If that confuses you, think about it as x to the 2x plus 5 over x to the 5x minus 3. Then, that's similar to, x over 5 over x over 3, and we subtract. And when we subtract those exponents, we get x squared. So we keep the base the same. The rule is that the base has to stay the same. So the fact that this base is a number, don't let that confuse you. So what we have is we keep our base the same, and it's 3, and then we are going to subtract the exponents because they are being divided. So I'm going to have 2x plus 5, and I need to subtract this whole binomial. So I'm going to have 5x minus 3. So I am going to keep my base at 3. I've got to distribute my negative. So I have negative 5x plus 3. So I have 3 equals negative 3x plus 8. Now, sometimes students see that negative and they want to move it to the denominator. And that is fine. But before you can move it to the denominator, if that's what you want to do, you need to factor a negative 1 out of it completely. So your negative 1 would be on the outside. You would have 3x minus 8 on the inside. And then if you move that to the denominator, it would be 1 over 3 to the 3x minus 8. So I just want you to be sure you're aware, because I see why people would want to do it is because that negative is in front of that 3x. But if you do it, you've got to take out the negative from the entire expression. So this is the answer right here that I was looking for. And this is the other correct answer if you moved it to the denominator. Okay. Number 2, 11x. And then that is raised to the power of x minus 3. So we can think about if I've got x squared, and that's raised to a power of 3, I am going to have x to the 2 times 3, and that gives me x to the 6th. So I've got to have 11, and then I'm going to have x times x minus 3. And I'm going to have to distribute that x. So x times x is x squared. X times negative 3 is negative 3x. Okay? So that is how that one works. For number 3, we are just going to rewrite as an exponential equation. Our base is a. That a stays the same. So our base stays the same. Our exponent is k. And the answer is going to be 14. So that is how we rewrite that. My next one is asking me to rewrite an exponent as a log. So this is going to be log. My base is 3. So my base stays the same. My answer to the exponent is my of. So log base 3 of 27 equals 3. So the answer to a logarithm is the exponent from the exponential equation. Okay. Now we're going to start using properties of logs, or the laws of logarithms, to rewrite into a single logarithm. So the first thing that I want to do is I want to take anything that's in front of a log and I want to put it with what is the index of the log. Okay, so we're going to do both of these first. So I'm going to have the natural log of x to the 3rd minus the natural log of x plus 3 plus the natural log of 7 squared. Now, some students might change that 7 squared to 49. I have no problem with that. And then some students may leave it as 7 squared. Probably the best thing to do is to change it to 49, but it's also okay if you didn't. So now I'm going to have a single log, and it's going to be a natural log. And my base for a natural log is e. So I don't need to put anything down there because I'm dealing with a natural log. My base is e. Now, the positive, or the things that we're adding, are what go in the numerator. So we are going to have x to the third in the numerator, and we are going to have 7 squared in the numerator. What goes in the denominator is what we are subtracting. So in the denominator, I'm going to have x plus 3. Now, leaving it like this is okay. Many students likely would rewrite it as the natural log of 49 x to the third over x plus 3. And this is a situation where we have multiple logarithms and we are rewriting it as a single logarithm. Okay, now we are going to go the other way. Okay, I have a log where I have one individual log and my base is b, and I want to rewrite it as sums and differences. So what I want to do is log base b is going to be what every single log I write down is going to be, log base b. I am going to separate my 10 from my x squared. If this was wx squared, students would probably very quickly write log base b of w plus log base b of x squared. But because that's a number, some students leave it with the x squared, and you don't want to do that. This one needs to be log base b of 10, and I need log base b of x squared. Okay, those are two separate things. The 10 and the x squared are being multiplied together. So when we rewrite it as sums and differences, we have to separate them. Now, I have a y to the third in the denominator, and I have a z in the denominator. Because they're in the denominator, I am going to be subtracting those. So I have minus log base b of y to the third. And because the z is in the denominator, I'm going to have log base b of z. Okay? Now, my next step is just to move those exponents in the front. So I don't have anything with the 10, so I just have log base b of 10 plus 2 log base b of x minus 3 log base b of y. And then my z doesn't have an exponent, but I still need to rewrite it, log base b of z. Now we are going to start solving equations. So for this one right here, I have 9 to the 2x minus 3 equals 1. 9 to the 2x minus 3 equals 1. I have a lot of students that do not realize that they can rewrite 1 with a base of 9. And so I have a whole lot of students that want to take the log of both sides to solve this. And you can. You can take the log of both sides to solve this. Okay? However, it gets more complex. It's fine to do it. It's 100% the right way to do it. But there is more opportunity for error. Okay? What I would encourage you to do is use the property anything raised to the 0 power is 1. So we are going to rewrite this as 9 to the 0 power. 9 to the 0 power is 1. Now I have the same base, which is 9. That means my exponents are the same. Okay, so I have 2x minus 3 equals 0. I solve for that. 2x equals 3. I divide by 2. So my x value here is 3 over 2. Now, if you solved it the other way, you would get exactly the same answer. It would be a lot more complex, but you would have the same answer, and you would have logs that once you simplified those logs, you would get 3 over 2. But this is the better way to do this one. The other way is not wrong. This one's just the better way to do it. Okay, number 8, we are still solving equations. As I am looking at this, always you want to try to rewrite in the same base. There is a relationship between 2 and 8. First thing I'm going to do is I'm going to take this 2 to the x, and I'm going to move it to the numerator. And when I move it to the numerator, that makes my exponent negative. So 1 over 2 to the x and 2 to the negative x are the same thing. The second thing that I'm going to do is I'm going to rewrite 8. Okay, 8 is equal to 2 to the third power. Okay, 8 is the same thing as 2 to the third power. And then I have x plus 9. So before I can do anything else, I need to go ahead and multiply my 3 times my x plus 9, because a power raised to a power, that's when we multiply. So I have 2 to the negative x equals 2 to the 3x plus 27. Okay, now that my bases are the same, I can rewrite my exponents as the same. Okay, so I have negative x equals 3x plus 27. I am going to subtract 3x from both sides. I am left with negative 4x equals 27. And for some reason, a lot of times students drop that negative, but this is negative 27 over 4. So be sure you've got that negative sign in there. Okay, let's move on to number 9. Number 9, we have multiple logs in the equation, and we've got multiple logs on one side of the equation. So first, I'm going to just rewrite the left-hand side. So I've got log base 8 of x minus 1. And because these are being subtracted, I have log base 8 x minus 2 minus log base 8 of x plus 2. I can rewrite that as a single logarithm, log base 8 of x minus 2 over x plus 2. So because that was subtraction, that means each of my indexes are being divided. Now I have a log on the left and a log on the right, and they have the same base, so I can remove those, and I can have x minus 1 equals x minus 2 over x plus 2. Okay, at this point, we multiply both sides by x plus 2 over 1. Okay, I'm going to go ahead and FOIL this other side, the left side. So I have x times x is x squared. X times negative 1 is negative x. 2 times x is 2x. 2 times negative 1 is negative 2. And then on my right-hand side, I'm left with x minus 2. So I have x squared plus x minus 2 equals x minus 2. So I am going to subtract x from both sides, and I'm going to add 2 to both sides. And when I do that, everything cancels out except my x squared. So I'm left with x squared equals 0. And so at first you might be like, ooh, what does that mean? Can I take the square root of 0? So if you're not sure, go on and try to take the square root of 0. And you will find out you can take the square root of 0. So x does equal 0. Now, we do need to go back and see what happens when we plug 0 in to each one of these. Okay, so let's look at my first one. Log base 8 of 0 minus 1. So what I have there is log base 8 of negative 1. This is what makes it undefined. We can't have a negative 1 right there. Having x squared equals 0, that doesn't make it undefined. It's this value, having the negative inside the index. That's what makes it undefined. So my answer to this, my final answer to this, is undefined or no solution. Okay, let's look at the last one. 2 to the x plus 1 minus 3 equals 29. First thing I've got to do is I've got to add 3 to both sides. I've got 2 to the x plus 1 equals 32. I can rewrite 32 as a power of 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 more is 32. So that's 2 to the 5th power. So I have 2 to the x plus 1 equals 2 to the 5th power. So x plus 1 equals 5. X equals positive 4. And that is our final answer.